Hello, we're going to be doing a synthesis problem involving alkyne reactions. So here is the synthesis of butylbenzene from phenylacetylene. So the first step will be drawing those structures. So from phenylacetylene, so I'm going to say this, 1, 2, 3, and that's your acetylene. Remember that I'm not drawing here the H's. There is an H there. And so our target is the butylbenzene. So we will have same phenyl ring, but then I'm going to have 4 more carbons. So 1, 2, 3, and 4. And notice what we need to add here. We need to add carbon chains. So here you have, other than the phenyl group, here you had 4, and here you have 2 carbons. So obviously we need to add 2 more carbons. The way to do that is using acid-base property of the hydrogen here of the acetylene, which is acidic. Let's remember that the pKa here is 25. So I can use a very strong base, such as sodium amide, to remove the hydrogen. So say that I use sodium amide then, and solvent can be ammonia. And when I do that, here the pKa of ammonium to ammonia to give, so the conjugate acid of amide, pKa is 38. So here we go, it's capable of removing the hydrogen. So what we're doing now is forming the conjugate base. So here I have removed the hydrogen as my conjugate base. So next step will be adding more carbons to the chain. Notice again, we have here 1, 2, 3, 4 carbons, and here I have, other than the phenyl, as I said, we have 1 and 2 carbons. So we need to add 2 more. The way we do that, we're going to be doing a nucleophilic substitution, and we're going to use butylbenzene to do that. Let me make that another color, yeah. Ethyl bromide for that. So what we're doing is then a nucleophilic attack. So here, remember that's in my SN2, that's an sp3 carbon. So you're attacking at that carbon, this one breaks, and then you'll be adding these 2 carbons to the chain. And so what we have at the end is phenyl, and then you will have 1, 2, and 3. And 2 more carbons, but we're not there yet. So what do we need to do to go from here to here? So we need to do a hydrogenation reaction. So we need to add hydrogen atoms across the triple bond. So what we're going to do then, since we just have an alkane here and an alkyne, we simply use hydrogen in a metal catalyst, such as platinum or palladium, to complete that reaction synthesis. Okay, so what we did here was noticing the structure of my target molecule in the reactant, realizing that I had 2 more carbons. So reactions to add carbons to the chain, here's one example. We're adding, using the fact that this hydrogen is acidic, removing it, doing an SN2 reaction over to ethyl bromide to add those 2 carbons to the chain, but to have the final structure, we needed to add hydrogen. So we perform a hydrogenation reaction. Okay, we will do more problems in another video.